I guess we're on. Good morning, everybody. Good to see you, or see you in the audience. I'm going to talk today about practical workflows with Mac VMs, subject near and dear to what I do every day. Just a bit about me. My name is Chapman. I lead the technology organization at MacStadium. I was pioneering in the development of a platform we have called Orca, which is a virtualization platform for cloud. And prior to that, I've been manipulating and managing Macs since 2004 in enterprise, which is, as we all know, an interesting problem to solve. A bit about MacStadium before I get into the meat of the subject. If you don't know, we're a world-class data center. We build top to bottom all Mac, so the servers are Macs, the interfaces are Macs, and the platforms we use are Mac specific. We believe Apple should be a first-class citizen in the cloud, and we really focus on making life easier for developers and admins and people who have Mac and enterprise needs. We have a couple of offerings. Bare metal, we call bare metal basically remote access to hosted Macs in a data center, but they provide a lot of capability and compliance and regulatory concerns handled. We provide macOS desktop solutions, so we're partnered with folks like Citrix, as well as some of our own technologies internally that give you the capability to have a high-performing desktop anywhere in the world that is based on any capable Mac you want. We have everything from Intel all the way up to the latest studios. And then we, of course, offer, and where the topic of this conversation is going to go, virtualization and orchestration platforms. These are heavily used in CI/CD for development and test, for anything that you would do on a mobile platform or any Mac target. We also are starting to find that a lot of the orchestration and deployment capabilities that typically were reserved for development and CI/CD are becoming more and more useful for portability, distribution, test, analysis, and things of that nature that are more useful beyond the scope of just development. So today we're going to cover a couple of things. We're going to briefly touch on virtualization on Mac so that we all have a level set. We're going to go over the tools and platforms that you can use. There are quite a few, and they have quite a range of capability. We'll then do a demo where we build a VM with a local virtualization tool. Then we're going to get into sort of the next evolution of not just using it on your desktop, which I think is the reference point for a lot of people for virtualization, especially virtualization on Mac. It's the using Parallels or something to run a Windows app or something. That's kind of the baseline experience. But what we want to really do is talk about it in the context of using it for Apple environments, Apple testing, Apple development. But more than that, once you do that, how can you collaborate, distribute, package, version control, scale, move it about the cabin, all those sorts of things. So we'll go through that. And then some final thoughts on virtualization and use cases in general. It is going to be sort of workflow specific, so I'll break it into sections by workflow, just so you kind of have an idea of what we're doing. So briefly, let's discuss virtualization. This is not new, obviously, technology that's been around for a while, and it's just the abstraction of hardware resources from the underlying machine. But for the most part, people are using it because it gives you multiple OSs on the same hardware stack. It gives you the ability to put multiple layers of software on the same machine. And it gives you portability and environmental isolation that you can easily use the same thing over and over and over. Again, partially why it's heavily leveraged in development environments is because they tend to be highly repetitive, highly iterative tasks where you're going to erase and erase and erase and erase. Which brings us to our use case for developers. Again, great for CI/CD. It's excellent for multiple users using the same type of reference images, but being able to apply those to different hardware stacks. And it's highly automatable and integratable. It's great for environment creation as well. Sandboxing is often the term used here, but you can sort of rapidly build initial reference configurations that you might use for your MDM scripting and deployment. You can create multiple environments for tooling and for scripting. You can also sort of experiment with different types of environments where you may want to create sort of a long-lived save state. Apple Virtualization actually does have the capability to do not just restore point, which you're familiar with from the hardware side, but also an actual save state to multiple levels on the machine. So you can actually sort of snapshot every step of the way when you're building something out. So that's useful when you're creating different machine states. Testing and validation is a big use case that we see quite a bit for the virtualization piece. People are needing to verify environmental assumptions. It gets tedious and painful on hardware, and breaking hardware or having side hardware that you're using to do terrible things to over and over, and it's nicer when you can just do it in a quick VM that you can kill without regard. It's also good for regression testing. Again, back to that saved state capability. It's interesting to be able to sort of continually snap the thing and then roll back to the various steps of it to see where things might have gone wrong. It's also nice to be able to capture the state of a machine in a QA scenario where you really want to almost validate what the user is experiencing in the virtual environment. Security and access control is another one. We start to see this more in the remote desktop case. And that comes from our data centers being SOC 2, ISO compliant, obviously physically restricted to access. You combine that with MDM and security tooling, both at the hardware layer and at the virtualization layer, and you've suddenly got an extremely locked down and extremely controlled environment. Not only that, but many customers want to have the front end and the back end of the user experience completely contained within sort of corporate network and corporate infrastructure. So a virtual user environment can actually interface to a virtualized development environment on the back end and never leave the walls of the company, so to speak. So that gets into kind of what we've already been talking about. There's obviously a couple of different kinds of virtualization and virtualization tools, but there's pretty big distinction between local and cloud-based virtualization. Here you're seeing icons for several of the tools. Obviously I'm biased as to which ones I put up top because those are ours, but Toolkit is a local desktop free forever tool that you can use for virtualization. I'm sure many of you are familiar with Fusion and Parallels. Anka and Tart are also tooling that people often use on the local desktop. On the cloud side, as I mentioned, we have Orca. It's a Kubernetes-based containerized virtualized macOS, which is a little bit of a twist, but it's used heavily in development. Tart and Anka are also in that ecosystem. Tart has something called Orchard. Anka has a controller that sort of collaborate with their tooling. And at the bottom we have VMware with the big not sign through it because as Apple made the switch to ARM, VMware chose not to follow with ESXi. So it's a bit of a challenge. It's something everybody needs to be aware of, is that a lot of labbing and a lot of sort of closet Mac farms were based on sort of free ESXi, and that platform's just not supported after 25. So it's one of those things that's sort of forcing a migration and requiring folks to take a look around. In the middle of that, there's obviously a BYO. All these technologies are either based on existing hypervisor frameworks or are built on the Apple hypervisor framework, which is documented, available, and you can build your own. So it's quite possible if you want to build something like a UTM tool or something like that, that you could take it on yourself and use the framework. So let's start going through some workflows here. What we're going to talk about here is a local VM creation workflow. So this is sort of the simplest base point to start from. We're going to grab a virtualization tool, create a VM. You take that VM, we're going to pull a source file, start it fresh so it has a clean OS to begin with. Build the initial setup, and then install some tooling and save it. So this is just the basic getting started kind of stuff. So I've got my friend Spike here. He's going to go get the one that we know about, Orca Toolkit. It's available on our website, and again, it's a free forever tool. So it's got the technology that we use internally in our cloud-based systems for Orca. It's got a component to it that understands and works with the hypervisor framework. We work with Apple directly and talk to them regularly to make sure we're asking and getting the things we need in the hypervisor framework. And I'm glad to say that Apple is pretty responsive to development needs on this and for the hypervisor itself, which is good to hear. They have honestly been putting changes in the framework with every minor and major release of the OS, so it changes a lot and quickly. Just a brief bit about Toolkit. You can use it to create and manage your virtual machines locally. It's got both a GUI and a CLI. Today we'll pretty much kind of just touch on the GUI in this talk, but we do have a demo later where we can talk about a bit of the CLI. It's really great for local developers to test and try things out. And then it also was originally built for the purpose of helping folks understand how virtualization performs. There is obviously tips, tricks, and differences between a physical environment and a virtual environment. And we found often when we were trying to help folks make their cloud journey into Orca that they struggled with not necessarily so much the Orca part, but how virtualization differed from their physical environment. So here I've got Toolkit opened up. What we're going to do is create basically a shell. And what you're seeing here is Spike saying, I don't have an image that can run macOS. So Toolkit will go to the Apple repository and pull down the latest IPSW. For those of you that don't know, when we switched from Intel to ARM, the format of OS changed to IPSW, which is akin to iOS and iPad OS. So you now need to base your virtual machines on an IPSW file. So all this did was grab an IPSW file from the repository, pull it down, embed it with the resource parameters of the local machine that were set in Orca Toolkit, and get it ready to go. So it's sitting now waiting to start. In this next bit, we're going to actually crank it up, and as you'll see, it'll pop the frame up, the VM will kick in, and we get the familiar starting up Apple. Obviously, once you get an initial OS set up, you would use something more useful, an MDM tool of some kind to script past all of this. Or you could save the state and have multiple versions of the VM already prepared, but we're kind of showing one of the use cases we talked about here, which is sort of initial OS setup and configuration, where you can then use this OS as a reference. But what we're going to do is, in addition to get the VM configured here, Spike's playing the role of a sort of a dev tool configurer person. He's going to pull down a couple of things for his teammates, iTerm. We're going to put in some VS Code. He's going to pull down the Go library, and he's going to add Monkey in and Homebrew so that we have the ability for this VM to be used by other developers on the team with those specific tools to start collaborating on a project that they're going to work on. So Spike's job right now is simply to create the base image, to install some of the fundamental tooling, to verify that that works in his OS image, and then to save that as a save state of this virtual machine. Once he gets done with that, what we'll do in the next step is talk about how we can distribute it locally, sort of in a peer-to-peer way, and how his teammate, who's going to be sort of test monkey, day zero guy, can do some development and verify that the tooling that Spike put in is working correctly. So again, Spike's more the admin in this case because he's setting up the tooling in the environment. And then we'll get to his partner Cameron in just a second. Right now, what you're seeing is him loading the brew install for a couple of packages and getting those set up on the desktop. I believe we just have Visual Studio Code to go. And this will be the UI tool that you can use. A certain point to make about virtual machines too is that in the development instance, often we do create a VM image with tooling in it, but we never look at the UI because it's scripted through CI and it's all command line or SSH. In this case, we're actually going to use it as though it were a portable developer desktop environment. So he is installing visual tools there. And I think we are almost there. He's quitting the iTerm, and we're good to go. So what Spike will do at this point is verify the machine's in a solid state, and he will shut it down. At that point, it just closes, goes back to the source application, which is Orca Toolkit, and waits for the next command. So now let's go into something a little bit more interesting, which is the local collaboration workflow. We're going to take that VM, we're going to package it, label it, prepare it, we're going to push it to a registry, and then allow Cameron, who's his partner, to pull it down to his local environment and work with it from there. What I'd like to do is explain some of the magic and the underpinnings of why portability is a little bit different. It's not just taking a full weight VM and slamming it around your network and that sort of thing. Packaging becomes pretty crucial and important and actually becomes a powerful tool. One of the things we do in Toolkit is wrap it in OCI, which is the Open Container Initiative spec. You'll see this used in a ton of places, but it basically provides standard luggage handles to put around your VM, and it gives it an amazing amount of capability with other tooling and other systems. So it just layers it slices and layers it up so that you have not just the macOS itself, but the environment, the runtime, and how you expect it to be distributed throughout registries, sort of packaged up as a manifest. In addition to that, we bake in compression because this is where the portability comes into play. Compression and deduplication will preserve sparseness, which means your 90 gig base image can be running at a 15 gig size, especially when you're passing it around to people with local environments with limited size on their Mac. It's important not to eat their whole hard drive up by giving them VMs to play with. But you can run this resting or running, and it can save you up to 80+% in these kinds of cases. The OCI bit comes into more play when we talk about registries. And this is where I was alluding to earlier, where some of the things you see developers start to do, where they're using GitHub for everything and Actions for everything, can actually be used in administrative cases and collaboration spaces, because you can now leverage that same registry as sort of a distribution node and a distribution pool, just to collaborate with your teammates. Some examples of registries, if you're OCI compliant, AWS has ECR, GitHub has their package registry, Google has an artifact registry, Azure Docker Hub, and CNCF, which is an open platform also. So now we're going to go into our Orca Toolkit here. He's going to create an OCI name. Now you'll see this name have a bit of a different format than the VM name he started with, and the reason that is the registry has sort of a naming convention where you need to specify the registry and the registry folder that you want to push it to in addition to the actual file name, and then you also typically tag it with a version number because as you'll see when we go look at the registry, versioning information is important, and it also allows you the ability to quickly toggle between different states and versions of the VM. But what he's done here is OCI wrapped that VM that we just played with before, compressed it, and pushed it up to our registry. Here's the actual registry, a snapshot of it. As you can see, it's just a GitHub registry. It's got 3 tagged images. The one we just did is the latest. There's a V2 tooling, and there's a V1. So as not to have me humiliated on stage, Spike was lovely and actually tested it a couple of times, which is nice. So now what we're going to do is go over to Cameron's desktop, new guy, both have Orca Toolkit. All Cameron now has to do, and what will make it better for him is additionally that compression and wrapping and versioning, is he just needs to point to the registry where Spike dropped the image off, type it in, ask for it, and pull it down, and he should get the fully ready VM instead of having to do the exercise Spike did. So again, it pulls it right down. Now what Cameron's going to do is start the VM up from scratch here, but as you can see, he didn't have to go through all the setup and rigmarole that Spike did. He can immediately open the tools that he knows should be there and are working. He's going to immediately start up the development project tooling. Now his job is not to mess with the tooling so much as to verify it can do what they need to do for the project. And since they're working on Go, he's going to pop open the editor and do a quick hello world for everybody. So thankfully it's Go and we won't have to wait for 700 lines of code. It should be only a few. And as you see, he's running a quick little program, testing it out, and there we go. Hello, MacAD UK 2024. Great, VS Code works. Bruce got all the right libraries installed, goes installed, the VM's working. He had no problems. He can report back to Spike, all's well. So this is all great. Everybody's sitting around. Devs are throwing VMs back and forth, or your IT guys are testing MDM configs back and forth in their lab before they bake it into the tool and push it out to the world. But we want to take it a step further now. What if you could do that and scale up globally? Scale up as big as you want it. That's where cloud virtualization comes in, and cloud virtualization workflows are important. So we're going to take the same sort of concepts at this point and push it up to Orca, which I mentioned before. We're going to then use Orca's CLI to dynamically address a fleet of data center-based Macs. And unlike the local example where I have to push it and my friend has to pull it, we have to know where the machines are. With this, it doesn't matter. It just matters that I'm asking for a VM and resource somewhere. And then on the heels of that, we're going to sort of flip the paradigm a little bit, and instead of working on a development use case there, I'm actually going to use that desktop like Cameron used it, but I'm going to remotely access it from somewhere else. And again, just to sort of touch on Orca, it's built for developers. It's command line driven, but it has CI plugins, a RESTful API, and a UI for command and control. So pretty much any way you want to interface with it, you can. And again, happy to answer questions later about it or show it in the demo space, but it has a pretty big tool set that you can either use for explicit resource scale, or you can have it do things more ephemerally where it just knows how to grab the resources you need. So again, in this case, Spike's VPN'd now. He's back on his computer. He's opened a terminal. You see he's on the Orca 3 command line here. Orca 3 has a command set. What he's going to do is, what he's actually doing right now is saying, I want to deploy a VM, go get it from the registry. I know it's called this Orca Toolkit Demo Latest. What Orca is going to do for him is find the registry, pull it into the cloud, identify that, grab resources across the data center, deploy it across those resources, and spin the VM up for him. So he's already spun the VM up. It's a very quick tool. You have a bit of a different power capability and scale capability. And all he's done there is open a remote desktop tool from his local Mac with the IP address and port that Orca created for that VM it created and natted through the cloud. And he's able to connect to the desktop, go in, and now he's going to check and see if Cameron actually did the development work he claimed to. And by typing a quick test in VS Code, he can see that it's been done. So he's just going to disconnect at this point and leave. But at this point, if he wanted to spin that VM up for 15 developers, 20 developers, 30 developers, 2 data centers, he's got the capability now because it's been pushed and scaled across. And that's pretty powerful, but we can take it even further. And that's something you can do with CI integration and automated workflows. Again, this stems from development use cases, but can be applied to multiple places. We're going to just talk about, I won't demo it for time's sake, but we're going to talk about extending your environment with a plugin, how that plugin can actually automate and orchestrate the tooling we just saw, and then how it can actually convert from what we've been talking about to this point are pretty static ephemeral builds. It's a VM, more like a pet. We know the tools that Spike and Cameron put in it. We watch them move it around. But you can actually go in a different direction and say, I'm trying to accomplish this task, build me a VM with the things I need, and deploy it how I want it. And that's more of an ephemeral use case. In addition to that, once you create source images, it's not necessary to always go back and manually manipulate the newest version of Xcode or the latest development library that your team created for the next build. You can use programs and plugins like Packer, like kubectl, Terraform's one people might be familiar with. It's more of an infrastructure as code tool. But what that lets you do is dynamically address the source image and script it so that each time your system runs, it goes and grabs the latest tools, fixes the image, and then scales that out. Here's a bit of an example of the Orca CI integration with the GitHub plugin. Many of you are probably familiar with GitHub and GitHub Actions. With this plugin, basically, GitHub can talk directly to the command and control in the data center. And so instead of doing what we did prior to this, we put in a little GitHub script that says, I want to run my test CI, I need a runner, I need version 3, and can you go ahead and run it for me? What it will do is go in, grab that image type, scale it. If I had 100 people needing that, it would scale it across 100. And it's all done through a quick bit of code, not a lot of back and forth. To the point of build automation, I have here sort of displayed Packer scripts and kubectl. Kubernetes, I know that's what we did for Orca. It's a bit of a brain twister for the Mac ecosystem, so I would understand if that's not a tool most folks are familiar with. But basically, it's a really scalable way to command a data center. But once again, you can see on the kubectl interface, it's listing out a whole fleet of Macs. You have the ability just through scripts and commands to change what they do and how they do it. And with Packer, Packer is more of a slicing imaging version. That's the tool you're going to use to basically script installing the right version of Xcode, installing the right tool package, and updating the image on the fly every time it runs so that it's always got what you need to do the job. So I know we covered a lot, and I talk really fast, so I apologize for that. But I'll give you a couple of final thoughts. Virtualization is a really powerful and flexible tool in your Mac arsenal. Apple, when they went to Apple Silicon, they made it a first-class citizen, and by that I mean it's got deep hooks into the kernel, it's got deep hooks into the hardware. They're constantly improving and expanding the use of it, and they're also using it not just as a tool for people like me who want to build VMs. They're actually using it as a fundamental capability in the OS itself. So for security isolation, for device interfaces, if you link a device into an ARM-based Mac these days, you'll start to see that they're going through virtualization and VZ frameworks, which are the same things that you use in VMs. The performance differences are vast compared to in the Intel world. Orca had probably a 20%-ish, it could be between 10 and 20% depending on what you were doing, penalty compared to bare metal speeds. On ARM, it can be less than 5%. And that's running not just normal development builds or normal desktops for users. That's running things like the latest AI workloads. So we've had some interesting experiences there. I would say it's not an either or an or. You just do local virtualization for fidgeting about, or that you have to go all cloud. I think it's a combination. And I think that combination can help you because you can have the local control you need to play and experiment, and you can have the cloud for scale and flexibility and distribution. I also think that the more you stretch and reach into tools like CI and like registries, you'll find that even if you're not using it for a development use case, versioning, the ability to roll back instantly, the ability to try out different OS versions, different tooling on the fly as quickly as possible becomes a pretty powerful capability. And then the last and not least, you saw the litany of tools that I listed for you, and you can build your own. I would certainly encourage any and everybody to kind of take a look at what Apple's documented and written on the hypervisor framework and how it works, because it's generally interesting for Mac users and Mac admins. But the virtualization framework and the hypervisor framework change extraordinarily fast. As I mentioned, when working with their team, and we meet with them a couple of times a quarter, they regularly point out to us minor incremental and beta versions where they've added more capability and added more capability. It's a growing capability on the platform, and they're continuing to try to push the boundaries of what it can do. So it's an interesting one to keep up with the tech stack, and I would just say whatever tool you pick, make sure that they're very acquainted with and very current with what they're doing with Apple. And with that, I will wrap it up and say, if you want to learn more, we would love to talk to you. We do have some demo time upstairs. We also have a booth out there, so definitely come talk to us. We'd love to chat. If you want to go check out the website, we're macstadium.com. A couple of things that I mentioned specifically in this talk were Orca, and you can check that out at macstadium.com/Orca. I briefly touched on Citrix. We did have a big announcement with Citrix about a month ago that we were partnering with them for remote desktops. It is in tech preview at the moment and scheduled to go GA in August, but if you'd like to learn more about Citrix remote desktops, we'd be happy to discuss that. And then we showed Toolkit today. If you go to that link right there, you can read about it and you can download it, and as I said, it's free forever, so if you just want to tinker about and see what it does, there's the place to go. Full disclosure on Toolkit, some of the features I showed today are coming in about a week, so the one you download today might be different in a week. Push-pull specifically are new capabilities that we just added. Thanks for your time, everybody, and I guess I'll take questions.
I don't see any questions in the Hoover app for you at the moment, Chris, but I know you're on stage with us upstairs after lunch. Does anybody, whilst we have a few minutes, have any questions from the live audience? If so, more than happy to run a live mic over to you. It doesn't look like it. I think everybody's holding out for the demo after lunch. So in that case, can we have one final round of applause for Chris, please?
Thank you.